Okay, well, I tried doing a live stream from up here, but the signal is absolute crap. So, it's a slightly different location than I chose the other night when I got fogged in. And it had a signal. This looked like a more promising location. And you can see the comet there in the shot. I haven't used an iPhone for this, bolted onto the eyepiece. Kind of digoscope style. Low-key, low quality, guerrilla style. Just so I could get something. Zoom in a little bit. You can see a decent part of the tail. It's going to get a little. It's going to get too noisy. I'll keep it right there. But I maybe can enhance this later on and make a second pass at this video. But this is how the camera's picking it up. YouTube just didn't have enough bandwidth to stream, and it probably would have been lesser quality because I have no control. At least I can control a little bit of the camera settings here. I'm like, the sensitivity a little bit. If that holds. So at least I have a little more control over the normal video camera app on iOS than I have over the YouTube app. Anyway, so this is all I could get. Probably only have visibility for another half hour, 45 minutes before it starts going down with the suit. At least there's no fog coming in tonight. There's no clouds rolling in. There's a low haze, about 15 degrees or so above the horizon. I'm up here on top of Skyline Boulevard, so I have a great view of the ocean if it were more clear, a little more bright. But here the cricket's going crazy, and so at least you can see a bit of the comet here. You saw my other pictures from several days ago when it was naked eye and real long tail, like 5, maybe 6 full moons long, just what I could see naked eye or in the picture. Friends who took much higher quality photos with better equipment and time exposures and stacking and all that stuff actually got really, really amazing shots of detail, a longer tail. You can see the gas tail as well as the debris tail. The gas tail has that kind of a bluish color to it. Sometimes it's in line with the debris tail, sometimes it's off to the side a little bit. This was like kind of bifurcated a little bit, like a lot of shots turn out in comets. But you never know. It just depends on what the comet's up to, the angle you're viewing it at, all that kind of stuff. So, yeah. So at least we're getting a shot of it here, live, to video. I would love to stream it live, it just wasn't in the cards. Luckily, there's a bunch of people up here on the left, so I have this whole area to myself. No headlights, no noise, just crickets. Occasionally get a few fast cars zipping through because that's what people do up here. They like to race late at night. Right now it's just beautiful up here. The moon is opposite me in the sky, so I'm down here a little bit. I'll switch over. I may even move across the street. You never know. I might have a better signal across the street. Stranger things have happened. And then I can do some shots of the moon, maybe some deep sky stuff. Because the sky is actually really nice up here. It's not perfect, it's a little hazy, but it's almost darker than down in the valley where I live. So I want to take advantage of a few things. I can maybe get the Ring Nebula, maybe get the Dumbbell Nebula, do some double stars. So I'll be up here for a while as long as my batteries hold out and if my signal actually works to do live, because I don't want to do a video of all that stuff. It's more fun to do it live. So scope is tracking pretty well. The comet hasn't moved. Normally by now in any lens or telescope, the comet would have moved because of our rotation. So the motor's doing its job. It's not completely calibrated tonight. I did get it collimated, so the optics are pretty good, but I didn't get the mount fully calibrated with Polaris. It's not fully polar aligned, but it's close enough for government work, as they say. So this is the comet. And again, I want to go closer, but as you can see, I'm already getting some digital artifacts from the noise with a slight digital zoom I did here. If I go any further, it's going to get real speckly looking. so I'm not going to do that. And I haven't had a chance to check where it is tonight, so I can't tell you what those stars are next to it right now. I will, and I'll post later. I mentioned the stars I took pictures next to 5 nights ago, 6 nights ago, whatever it was. Serpens, one is a star in Serpens, actually they're both in Serpens Cauda, tail of the serpent. And yeah, so here we go. As promised, here's the comet, as live as I can make it. I started shooting this around, well again I can't tell the YouTube app, but so I've been going for the YouTube app or the video app. I can't see the clock on this one either. If I tap, I will disturb videos. Damn video app won't let me see the time either. But I started around maybe 8:45, something like that. Slightly after that, and I've been going for almost 7 minutes. So I gave you a timestamp. So again, it's not live, but it was a live moment in time. Here comes a car. Too many. As you can see, I'm not properly polar lined, so it is drifting a little bit. So let me adjust it. My little control box. So there we go. Much shorter tail. And nucleus is not nearly as bright. A little head of the comet there. But and you can see the stars are twinkling because seeing conditions up here are dark enough to see a lot of stuff, but it's not steady seeing. It's the twinkle twinkle little star thing. It's not just looking through a chunk of atmosphere. The atmosphere is dynamic. It's shifting because of thermal variations, wind, all kinds of stuff. And it's just making the clouds twinkle. Can't help it. But with the comet, it doesn't really matter because you can see that the head is in focus, and the wispy tail is always going to be soft anyway. So, but this sucker is in focus. You can see by the stars are pretty good pinpoints. They're just twinkling quite a bit. I'll try to adjust a little bit just for fun. Let's see what it does. Going to get much better than that with this configuration. Again, this is an iPhone bolted onto an eyepiece with one of those really cool camera adapters you can buy for taking pictures of birds with spotting scopes with your camera, or actually sharing it with 10 people at once with your scope so they can all see the screen, which is really nice. Great for doing talks when you're in a group. And no one wants to wait in line for 10, 15 people to look at something. Sometimes it's already gone by then. With the spotting scope, in this configuration during the day, you can share birds and whatever else you're looking at with everybody in the group, and they all get to see it before it flies away, and you can record at the same time. So it's a win-win-win. It's not the best view because it's not a lens, it's a spotting scope, so the optics are designed for your eye, not for photography. But I've taken some pretty cool shots in there that I haven't gotten any other way, and I didn't have a giant 500, 600, 700, 800 millimeter lens with me, which, you know, it's like $5,000 for a good one, fixed focus one. Fixed aperture, fixed zoom, no zoom lenses, and they're pretty incredible. But you know, $5,000, $6,000. I have a bunch of friends over the years who are photographers, nature amateur photographers made a living out of it, but also did it for fun. And that was their main hobby, so they dropped a bunch of money on that. If you're into the synthesizers, you're into telescopes, you're into microscopes, you're into collecting books and CDs and old albums and everything else that people are into, it's a little crazy. So it's hard to have so many different hobbies. It's much easier when you're super into one hobby. But I've always had a lot of different interests, so I get to dabble. I don't get to have some of the best equipment just because I can't afford it all. But have fun with it anyway, so no complaints. What is that next to it? It might actually be. I should have looked before I set up, but I was in such a hurry when I got up here because of traffic and worrying about getting fog and clouds again. I don't want to waste tonight because it takes a fair amount of time and gas money to get up here. So I didn't get a chance to fully vet what I'm looking at here. So again, I don't know the stars in the shot, but that also looks like there's a Messier out there. I think that might even be a globular cluster in the shot. Because I know that other stars in focus, and the other little guys next to are also in focus. Oh wait, no, I'm sorry. It's an artifact from the software. False alarm. Let me readjust this here. See some more scintillation there in the atmosphere. It's a combination of noise from digital zooming and atmospheric conditions, and sometimes the app tries to autofocus when it shouldn't. I didn't have a chance to set up my DSLR app on here with the right settings. Again, I just wanted to make sure I got it because it looked like it was starting to get hazy. Busy again, lots of cars. So I'm just happy to get any shots tonight. Just last time I was up here, as you saw the short video I put up, maybe it did, maybe it didn't. It was a complete wash. By the time I got up here, it was already hazy, the clouds were rolling in, fog started rolling by the moon on the other side of the sky, and all of a sudden, all over the place. And so I just spent a little time looking at the moon, just handheld live stream. Some little laser demos for you guys, and then I packed it in because there was no use setting up the scope when the sky's that bad. There's nothing to see because the moon is all messed up too. I mean, it was fun looking through the live stream just through the camera at that kind of moonbow effect. It wasn't a classic moonbow, which is caused by high altitude ice crystals in the atmosphere, and you get this nice diffraction gradient effect causing this perfect rainbow around the moon, circular rainbow called the moonbow. It's also often called the 21-degree halo because it's generally because of the nature of the moonbow, how it's formed. I haven't read about this for a long time, but from what I remember, it's 21 degrees, meaning 21 degrees in the sky. So it's like about a fist and a half. At arm's length is about 21 degrees, something like that. I'd have to double check, but it's a good chunk of the sky, and typically that exact size every time it forms around the moon. But you don't get that other bullseye effect around it. You just get this nice little thin moonbow, and it's often quite hazy those times of night because there's a lot of moisture in the air anyway. But the ice crystals are causing the little halo there. And it's fun because it's just, you don't see it that very often. And most people, when it's really cold at night, unless they're out, partying or they're traveling from place to place or whatever, they usually sleep and a lot of this cool stuff happens. And it's cold, you're not going to hang out outside unless you're just a night person or you're hiking or going for a night walk or something, walking your dog. So it's missed by a lot of people. So I see them all the time because I'm always out looking at stuff. But the one the other night was kind of weird because it was more of a bullseye effect, almost like a double moonbow with a lot of thick moisture in between the rings. So it looked more like a bullseye effect. And it's a similar phenomenon, but I think it's not caused by ice crystals or maybe the same orientation of ice crystals. Again, I'd have to look it up. There's some really great books on this stuff, even stuff from like 50 years ago or older. I can't remember. There's one called the author is M. Minnaert, Minnaert. So I think it's a French person. And it was called something like Refraction and Light Effects in the Open Air, something like that. It's a funny, long-winded name. Excellent book. Explain all these atmospheric phenomena like moonbows, sun pillars, sun dogs, other strange things you'll see in the sky. Just atmospheric phenomenon caused by weather effects and viewing point of view and all that kind of stuff. So, like a lot of people don't know this, but generally, when do you see a rainbow? If you're looking at a rainbow, well, the sun is usually directly behind you. So, if you want to see a rainbow and it's rainy, or it's potentially rainy, or was raining, maybe it's raining in the distance, just look opposite the sun in the sky. You'll most likely find one if it's going to form. That kind of helps you find them instead of just randomly finding them. So learning more about the sky and the atmosphere and the weather systems isn't just for safety reasons like hurricanes and tornadoes and stuff like that, like all the horrible disasters happened recently. But it's just fun to go out and look at stuff and learn about how the sky works. Close to home, not all this astronomy stuff necessarily, just stuff in our atmosphere. It's pretty cool. And it also helps you understand, I shouldn't have gone out tonight because the weather systems have been changing and I've been monitoring this and that, and now I understand, I probably shouldn't drive all the way out there and get stuck with nothing to look at except for fog and clouds and a fuzzy moon. If I had paid more attention to the weather that night, I would have realized, probably shouldn't have gone. Even though by me it was fine, driving 30, 40 minutes away and the time it takes to get there, a lot can happen. So, all right, I think that's pretty good coverage of the comet here. So, as you will see, I'm going to just upload this as is to YouTube. So it's like a delayed live thing. I'll do this as an instant premiere, so it'll be like a fake live thing. So that way I can just be in the chat, chatting with you guys, and you can hear me yapping away on this stupid video. So, so it's almost live. I've actually never done a premiere before on YouTube on any of my channels, so the first chance for that to come out. So I want to experiment with that anyway. And since some of you guys probably either were asleep, my friends abroad in the UK and Germany and other places, Denmark, I was going to have, it's good that I didn't plan all this stuff with Henrik tonight, because he offered to do some live space music with the synths, simulcast with this while I'm doing it, and it obviously didn't happen because I didn't have my stuff together. And even if I had gotten up here and everything was working, I got a proper signal, I was in a mad rush to get to the object. But because I picked an area that was a perfect place to view it, but not good for signal, it wouldn't have worked anyway. I couldn't do my live stream. I certainly couldn't stream music. Take even more bandwidth up to do that. So the good news is I can take the album I got from Henrik that I was going to play tonight, and I can play that. Since this is a video, I could go back and Premiere. I can add the music as another channel at a suitable volume, and then this video with that will be my instant premiere on YouTube. So it'll be just like I was playing the music I was intending to play tonight, not his live one, but just the downloaded music. So the Premieres is a good option. I'm glad they offer that, so you can kind of either show something all over again, maybe people missed it, or you want to make it more of a social scene, or you want to, again, like in this case, a fake live kind of presentation. It's live for me right now, but later on I just may play back. And Premiere allows the chat part to still happen, which is cool. that's a big part of the fun thing for me, is getting people's comments, feedback, questions, and just hanging out. That's important. So yeah, I think that's probably long enough. Let me get over a little bit. Let me zoom back out again for reference. You see how small it really was in the sky. Yeah, see, it got so far away. Exposed, and then you got really, really faint, because it's a hell of a lot fainter than it was the other night when I was taking those pictures. So I barely could find it tonight. I basically dead reckoned it from an app, one of my cool astronomy apps I have on my phone. I just did the typical star hopping technique, where you see a couple bright stars in an area and you triangulate the third object, off of those two stars, and that's, you star hop from there. So I have that little, if you watch my stream last week I think it was, on equipment and getting ready for the comet and all that kind of stuff, I did show a couple gadgets I'm using tonight. One is the reincarnation of the Telrad, which is used on tanks. I think starting in World War II. Pretty much in World War II, I think they started using it. And it's this rangefinder thing where it bounces a virtual beam onto an optic. And so you're looking down this optic at the top of the tank. Not a scope, but just like a glass plane. And it's, the right kind of like how teleprompters work, those see-through teleprompters. There's an optimal angle for the reader to read the text, but you can't read the text because it's beamed at an angle. So it's kind of like that. You don't see a beam anywhere but directly behind the object in your line of sight. And it puts this virtual red dot, or in the case of a Telrad, a target, on the sky, or right in front of you on at the enemy tank or building or whatever you're trying to shoot. So it allows people to still have their field of view, their peripheral vision, and a nice targeting thing that they can they know it's calibrated, just boom. Off you go, shoot, shoot, shoot. You don't have to have your eye in some rangefinder and then the tank shakes when it goes off and you get your eye poked out. So it's a very clever thing that allowed you to have a lot more flexibility and still keep your wits about you, because the guys on top of the tank, they also had to see what's going around and they might get shot at. So you want to have your peripheral vision and your ears up there listening while you're also rangefinding. So anyway, they adopted that. So again, another example of military isn't always evil, right? You get some cool technology coming out of military, repurposed for things like science and hobbies and things like that. So it's pretty cool that it worked out. And so I'm using a Telrad to dead reckon. I've been recalibrated tonight, so I can basically have. I know wherever I put the dot, pretty much is going to be dead center, and I tested on a few things. I may, if I can move somewhere and get a live stream going, I'll try to get some objects here, like Albireo, a really nice double star in Cygnus. So I found Albireo before I went to the comet, and actually just to make sure that the targeting is working. And then I just dead reckoned from the two main stars. In this case, it was Vega in the constellation Lyra, and it was Altair in the constellation Aquila, the Eagle. And I essentially dead reckoned those down to a point, and then just off a little bit, because this is down in Ophiucus, constellation Ophiucus, kind of near Ophiucus and Serpens Cauda, something like that. I forgot. A couple of constellations that I kind of never really look at down there. And I just dead reckoned to a couple smaller stars once I was in the general area. And so it only took me a couple minutes to find it. So again, it's not really naked eye anymore, at least not from here, because it's still not that dark. There's almost a full moon out. It went past full a couple days ago, but very bright out here. You don't need any flashlight or anything. You can just use the moon to look at everything. But so that's, let me pinch in. That's pinched out so you can see the reference. That's how big the comet looks at low power. The bird going crazy over there. That is. That's definitely not an owl. There's no owl around here I know that sounds like that. And quail sound a little bit like that, but they're asleep by now. Not sure what that is. Luckily, there's a really cool app. Cornell Laboratory of Ornithology has a really good bird app. Not only is it good as a field guide for birds, but they added this really cool feature. It's basically Shazam for birds. Oh, there you go. Great horned owl. Hear that? Wait till this car goes by, you'll hear it. I love great horned owls. I guess the owl's making that noise too. That's weird. Never heard a great horned owl make that noise. It's like it's going nuts. Almost sounds like a great blue heron way out of place. Anyway, this app you can use like Shazam and look up bird sounds. It just listens to recordings or live. Really cool. Let's see if you'll imitate me when I do it. It's a funny noise. I get to combine two of my favorite things, birding and astronomy. This is great. The kid's having a meltdown. Alright, let me zoom in again. I'm getting some damn noise here. I'd like to switch to another app. I want to keep this as a contiguous video file. It's just easier. So I'm just going to set this. Still kind of see it. Turn the sensitivity here. Still there. Now you get a lot more background noise from digital zoom artifacts. That's not too bad. Again, this whole thing's less than ideal, but at least it's something. The initial bit, it's getting much lower in the atmosphere now. My telescope is almost horizontal. And considering I'm at a high point, horizontal is very, very low. Check my toe around here. Yeah, so I'm surprised I can still see it in this. There's some muck over there. But it's still looking at some hills in the distance, so it's not completely my vantage point. If I look more to the left, I get more of a sea view if it were bright out, if it's sunny out. The exact place I'm looking has a little bit of a hill still, below where I am before you can see the water. So I'm probably about 15 degrees above it's probably about 20 degrees above the horizon right now. It's pretty low. So definitely less than ideal. No matter what you look at this height above the horizon, it's usually crap, because at the zenith you're looking straight through the smallest distance, smallest thickness of atmosphere you can. It's just straight up, straight through the atmosphere. Because the atmosphere has a thickness to it, as you're aiming down, lower, you're looking through a thicker piece of atmosphere, because it's like a shell, right? So as you go down toward the bottom, it just gets into total muck. So if you look at a bright star like Sirius coming up in the winter by Orion, and it's real low in the horizon, you could catch it coming up. Nice horizon view, a nice low part. It looks like, is that an airplane or a police helicopter or something like that? Because you see this star blinking, blue, red, white, blue, red, white, all these different, like it's strobing in different colors, and it's just the star getting mashed around the atmosphere because of the thickness of the atmosphere, the turbulence, the bad scene that night, the whole works all coming together. It's pretty interesting stuff. Not good if you want to look at it. If you want to get a nice, clear, crisp image of a star, like a nice pinpoint image. So that's when you wait for it to rise. I'd say at least 30 to 40 degrees above the horizon before even really trying to look at it, unless you're desperate. Like a lot of times I've looked at Saturn up at Yosemite from Glacier Point, which is an incredible view up there. And even low in the horizon, it looks pretty good up there, even though it's like the worst case scenario. And sometimes I had to look at Saturn just before the sun came up. So I'll look at Saturn in the muck because I want to see Saturn, and it wasn't as bad up there as I expected, because it's so clear at almost 7,000 feet, around 7,000 feet. And it's just very steady, clear. So it's sometimes it's worth it, and especially if it's the only look you're gonna get at something. Maybe the planet, you're not up that time of the morning, and you won't be able to see the planet during a normal night for months and months. So instead of waiting, just go look at it when it's less than ideal. At least you get to check it out. For people who've never seen it, they'll just look at it any old way because they're just happy to see it. But Saturn I've seen, I can't even count how many times I've seen it now. Probably 500 times in my life, maybe more, I don't know. So I'll still look at a crappy view of Saturn because I love it. But just depends on your what you're into and how picky you are. I think I lost it now. I think it's gone. Yeah. It's gone in the muck down there. It's pretty bad. So anyway, while I have this bolted on, I'm going to go cruise over to the moon real quick, just because I can. Actually, I think this will pick up Albireo. I'm not that far from Albireo. Let's try it. Here it goes. There it is. Nope, still slewing. There we go. Make sure it's still there. Yep, that's it. Let me center it because it did get off a little bit. So if it holds up, and I zoom in, you'll see two stars. And of course, the app doesn't know what to do right now. And what's cool is they're slightly defocused, which is a trick to see the color really well. Sometimes when stars are pinpoints, especially with your eye. The camera's a little more forgiving because it's able to grab things in a different way. But with your eye, sometimes you look at some of these things and you say, well, what colors do you see? First of all, we all see colors slightly differently, potentially, based on your, quirks about your eye, right? Oh, and by the way, check this out. Let's see if this picks it up. I'll put my little pointer into the view. There it goes. There's my laser pointer in the field of view. See if I can get pointed right at it. There. Yeah. So I'm down here pointing. Here, there's Albireo right there. And you can see right at it. Now this is higher power, so the laser looks like it's dancing around. But from down here, they can't tell. I'm pointing right at it as far as they're concerned. So the beauty of green laser pointers are really great for teaching people and finding stuff. So here's Albireo. It's a double star, and it's called the Eye of Cygnus the Swan. So the Northern Cross is also called Cygnus the Swan. Northern Cross is an asterism. It's a formation inside of a constellation. So when you first look at it, hey, it looks like a cross, right? Like a Christian cross. But the constellation is a lot more than this. The cross, the wings, the cross that forms the wings part going out, go way beyond just the two bright stars on either side of that axis. And there's more to the tail end as well, which is a really bright star called Deneb. But I wanted to show this one because this one is a really easy one to find. It's very colorful, so people go ooh ah when they see it. And part of the fun thing about doing astronomy shows for people, star parties, all that kind of stuff, is the ooh ah factor. They see the moon for the first time in the craters. It's like, wow, that's amazing, right? And no matter how many times I look at the moon, thousands of times, it's still fascinating to me. It's just, you get the ooh ah from your own point of view, right? And then you see the comet of Shirley, that's pretty much ooh ah when people get a good look at that. And double stars, and the galaxy when you can get a decent look at it, and the planets. A lot of things can be ooh ah. Meteor showers, stuff like that. But these little double stars can be beautiful. You see right there? There's a golden white companion, much larger, and a little blue guy next to it. Can you zoom in and not screw it up? Yeah, not bad. So if I focus this a little more, potentially. So defocus, you really see the colors there. You see gold and blue. Yeah, got a little finer shot on there. And that's about as good as it's going to get with this projection setup. You can see the star to the side is a nice little pinpoint, so it's definitely in focus. It's just the conditions aren't beautiful. It's a little hazy. Here comes the speed demon. People wonder why they have accidents up here all the time. Motorcycle racers, weekend warriors with their cars, a deer comes out of nowhere, someone's like crossing the road, or they just anticipate the road incorrectly and overcorrect and wipe off and fly off the side of the road. Now there are a few drop-offs here. Not right here exactly, but there are a few where you can drop off and roll down the hill. And if you haven't died from the crash, you'll die from rolling down the hill most likely. Anyway, so there's a nice view of, again, it's fuzzy and it's not ideal, but it's a pretty good view of Albireo. And that's all so there you go. Double star and Cygnus the Swan. So Cygnus, Aquila, and Lyra form the summer triangle. And so they're still up, even though it's not summer. Although they still daylight savings. It's still visible right now. It's still pretty early at night, but summer triangle stays up almost all summer, all night during the summer. But as it gets more into fall, it's going to go down and see some of the good stuff. So, I'm already seeing some kind of cloudy, wispy stuff going through the summer triangle. So it's definitely hazy. And so yeah, it's not perfectly set up or anything, but get a nice view of it. I was hoping it would turn out, and it actually turned out okay. So now I'm going to try, this is going to be a stretch because it's pretty bright, but I bet it's not going to show it. Let's see if I can find M57, the ring nebula. Wow, duck cluster. That's pretty cool, actually. It's going to show up. Ooh, that's a, yeah, there's no way that's still up, is it? No. So here's what I'm going to do. Yeah, M13 is still. It's too low. It's a nice kilometer. I'm just being lazy here and going through a kind of what's up right now in this little control box. Swarm nebula is pretty cool. That's not. Ooh, there is something real bad. Alright, I'm starting to see some haze now. Definitely haze. Foggy haze coming in. Let's quickly go to Dumbbell. Just for kicks. Let's see. Because it's not as bright. No, it depends. Not usually as bright as the ring nebula is. Alright. Let's see. So I can zoom in. Yeah, I'm not really picking it up. Not really picking it up. Probably because of haze and probably because it's a tricky one. With this iPhone configuration. If I had a custom app where I could dial in the ISO and the shutter speed and other stuff, I'd have to stop the video and do that. So let's forget that one. Let's go to ring nebula. Let's see what that one is. Let's go to that one. It's small, but it's a little brighter. Definitely not seeing that. Turn the bright sensitivity all the way up. Hopeless for tonight, anyway. So yeah, Uranus is up, Neptune's up, but good luck with that. Got some quasars listed here, but those have to be perfect conditions, and you have to have a chart most likely to know what you're looking at. Another speed demon. I'm close up to the moon. Let's go to the moon first, get it in focus, and then I could try Andromeda after if I feel like it. Alright. Got a little glitch, and I'm on the moon for a little while. Looks pretty good here. I'm using the, had to use the manual app called DSLR camera. So I have more control over the exposure and the focus. Some of the stuff is this bright without using the stop-down masks on the aperture of the telescope, because this is an 8-inch. Normally you'd have to stop it down, so if I put my hand in front, you'll see stopping down the aperture quite a bit. But this camera app will do a pretty good job, as well as have some override features to compensate for that. The Apple camera wasn't quite as good at it. Sometimes it would jump around. This one's a lot more stable, so I'm able to use this one. So now I can do a slow tour of the moon. Now, because it's almost full, it was full a few days ago. Let's see what more stuff. I can also contrast adjust it, so it's not just blowing up in your face. This is famous right triangle. Copernicus, Kepler, and Aristarchus, and I forget which order it's in. I think it's Copernicus in the middle, Kepler, Aristarchus at the top. I think that's their order, but it's famous right triangle of craters. I was always finding on my telescope as a youth, and also you can find it in binoculars pretty easily. It's very, very bright. I don't have a map with me, but I'm just remembering some from the past. So nice bright craters. I got these mare, what they thought were seas back in the old days, of just dark lava flows that are pretty smooth, but also have a lot of the powdery moon dust called regolith. They're actually, again, the moon hoax people and stuff. They're spacesuits worn by the astronauts, brought back from the moon, and they're on display at Cape Kennedy. Used to be called Cape Canaveral. Or maybe it's the other way around. I was there many, many years ago, and I think they call it Cape Canaveral still. Cape Kennedy was the old name. In any case, you can go down there in Florida. It's beautiful. You can do a tour of all the launch sites, including some of the SpaceX sites, some of the old, kind of no longer used Apollo sites that they launched from, and of course the space shuttle sites that they stopped many, many years ago. And you could sit in one of the museum areas, which is one of the common viewpoints. When they would have a launch, you could actually stand there and get your body heavily vibrated by the low frequencies as the vehicles took off. It's pretty impressive. Friends told me. I never got a chance to go when they were still doing it. But they have like recreations of famous events. There's the actual mission control room you walk through from one of the Apollo missions, or a group of the Apollo missions, and they have it all automated now. So there's a computer controlled. They've gone back in and changed the wiring and everything, so it lights up. It has speech. It has areas highlighting with spotlights, so you know this is where the station they were talking about this. This is the station we're talking about that. There's famous recordings of all the guys who were there. Really dramatic, fun kind of thing. And then you can go inside this huge hangar and see a Saturn V rocket laid down on its side, and walk the entire length of it, laid down on its side. You can see the spacesuits worn by the astronauts. You can see the moon buggy. You can see the lunar lander. All kinds of shit that is real impressive. And the astronaut suits had regolith on them. Now I have friends that work at NASA. They have samples of real moon rock they've been studying. They also do constant moon missions. The one where they rammed something into it about 10 years ago to study subsurface, looking for water, ice on the moon, and they found it. They did LRO, Lunar Reconnaissance Orbiter, high-resolution mapping of the moon, which is where they found perfect timing where they took the shots. So you get the sundial effect, or if you take low-angle shots, you can have the equipment on the ground still there from all the astronauts, all the lower stages from the lunar landers that are left behind, casting shadows like a sundial. And what's even cooler is if you take the high-res photos and you do some enhancement on them, knowing the mission parameters. Like they had some hiking missions where they hand-carried experiments away from the launch site so they wouldn't contaminate with all the fine dust. And they didn't have moon buggies, and I think it's Apollo 14 or something was the first one to have a moon buggy, something like that, one of those later ones. But the earlier missions brought experiments, and so they had to hand carry the experiments. 2 or 3 guys hand carrying like a little hiking trip to drop this off and then go back to the vehicle and take off. No moon buggy. So they also went and studied some craters in the area, did some other stuff. So one specific mission, they went to this little area called Cone Crater. They also went to the other side of this little valley to drop off the experiment, and they went back, did some stuff around the thing, and took off in so many days to come back home. And their hiking trails are still on the moon because there's no weather system there. There are some little micro, kind of like, it's not really wind, it's some kind of, a friend of my friends described it once. They were doing some studies on it. Some little artifacts that are wind-like, caused by, I think it's electrostatic disturbances, magnetic disturbances, something like that, that makes the fine particles kind of dance around sometimes. But the stuff that's left there is left there. It's not like Mars where you have dust storms that actually cover the planet, where you can't see any land features for a while. It's kind of this yellow, creamy color. And then the dust storms clear, and now you can see the reddish color again. So, and the dark features like Syrtis Major looks like the country of India, and a bunch of other stuff. So they had all this stuff, they studied, and they brought back all these pieces of rock and samples of regolith, and there it is. You can see it on the astronauts' clothing still. They sealed them up when they came back from the trip, so they were basically uncontaminated as much as possible. So it's just cool to see that stuff. So here's more moon stuff. Just moon yakking, not showing anything. Just do a quick tour around the moon. Maybe a quick shot of Andromeda if I can get it. If it's bright enough with the camera. But yeah, some really cool formations here. And again, I'm not even on the highest power I can do. I'm just screwing around with this camera. So this is where it gets interesting. You get near what they call the terminator, which is the edge of the moon that is either waxing or waning. So there's some contrast, some cast shadows and stuff. This is always the most fun area, because you get all these little details. When it's full moon, it's a pretty boring object, other than some of the craters and just the overall shape and color. But this is the fun stuff, all this crater stuff here. You really see it when you start hitting these little terminator formations. There's a nice dark line. You see the line is broken up because of altitude and dips and various levels of craters. It's kind of jagged looking, it's not smooth. That's really cool there. So because the moon, let's show you. So these are the three mare here. Mare Crisium, Mare Tranquillitatis, and Mare Fecunditatis. And again, I forget which is which, but these kind of, it's almost like the Great Lakes connected together as far as what they look like, even though they're not anything close to any body of water. But look at this on the right. Occasionally you get this exposed because the moon doesn't 100% face us the same exact way all the time. So if you look at the moon long enough, you'll see these perturbations where it has a bit of a wobble. And you're seeing Mare Orientale right there. Don't always see this that well, at least from my experience and from what I've read. But right now the moon happens to be turning that way a little bit, So we're seeing more of Mare Orientale than we normally do, from what I remember. I could be wrong, but I remember barely seeing the edge of this most of the time when I've seen it. But this is a nice big chunk of it, because again, the moon is locked in orbit with us, and it generally faces us, which is why the far side is all pockmarked, and this side is very few craters compared to the back side, because the far side always is the far side. There's just some slight perturbations side to side during the orbit, and so you may or may not see more or less of this Mare Orientale here on the side. So it's just kind of fun looking, and it's really dramatic here with the way the shadows are cast right now. So I always like this structure. Let's see if I can zoom in just a little bit without screwing up the image. Yeah, that's max for this camera. But yeah, nice view there. Some other craters around it, I don't know them, but again, I can always get the moon map out and check them out. But Mare Orientale, it's really nice. Let's go back down here. So what the contrast is and the exposure is holding up. I like this app. It's much more controlled than the standard. Another great horned owl down in the way. He may have moved. Moving away. Look at those edge craters. Those are great. So again, slightly higher power. These are really fun to look at. And then you basically have, that's Tycho right there. Big old crater you can't ever miss. When you get a good view with binoculars or a small telescope, you can't miss Tycho. It's the massive crater kind of in the south, and it has these giant rays because it's a massive impact. I don't know the figures on it, but pretty sure they know. Ooh, a nice meteor just cruised by across the sky. I'm sure they know to some overall dating they've done with the rocks and stuff, as well as the some simulations, or maybe they don't know. I'm not sure when some of these impacts actually happen. But Tycho's really impressive. If you get more contrast, you really see the rays. Right now, you can't see the rays going out that well. You can see a few spikes, kind of like a north, south, east, west there. But it has rays in all directions because of the debris. It hit at a certain angle, a giant plume shot up, and then it spread debris in all directions. So it's made this really, really dramatic display compared to some of the craters. And it's just so big and so bright. It's really stands out. So I like Tycho a lot. It's fun. That's about it for the moon. Let me go back out a little bit. Get a little bit. I'm also getting a little bit of an exit preview. Artificial terminator here, and the way it is in the scope. Let me see if I can adjust it real quick. There we go. A little more lined up with the eyepiece now, so I can move this over. It's almost the entire moon. Zoom in a little bit more. See Mare Orientale on the edge there. That just showed that revealing itself. So yeah, it's almost a full moon, but there's a bit of a shadowy bit there. It's starting to. It's a waning gibbous moon. So waxing is when it's growing to full moon, and waning is when it's leaving full moon into a crescent and then back to new moon. So there's a nice shot of the moon. Let's leave it there. Let me go back to. So let's set to noon. Leave it there. I think I have it on auto because So auto exposure, manual focus. I'm gonna leave it here so the focus stays. Zoom out a little bit. So it's gonna be more light. And let's try to find Andromeda. Let's do some dead reckoning. If I can find it in this condition. It's not the best condition. You already saw a double star, you saw the moon, you saw a comet. So let's give it a galaxy. Oh, these dot finders, Telluride style, are so awesome for just getting somewhere really quick and dead reckoning. Let's see how we're looking here. Let's see. Stars in there. This camera's not behaving. Let me try jumping back to the Apple app. Be right back. Deep sky. Galaxies, yes. See how that looks tonight. It's tricky because the moon is not full but close enough. And it's also hazy up here now. It's gotten worse. So I might see something, I might see nothing. But because this is a naked eye object, even though it's 2.2 billion light years away. Oh, I said billion, 2.2 million light years away. It's like the part of the scene you can see naked eye. It's almost always impressive, but it's tricky tonight. It's a tough order. Red. All right, so I had to crank it up a bit. And again, the scene conditions aren't ideal. It's a little hazy out here, a little moisture in the air. But that's a good chunk of the Andromeda Galaxy there, that fuzzy ball off center there. I'll see you see when I move the scope. It moves with the scope. There it goes. So it's not a smudge. It's a giant galaxy, very similar to our own Milky Way. Move back to the center a little bit off so I can see it to focus better. Let's go. Oops, wrong way. It's off center, and it is focused, but again, the image quality is not amazing. A lot of noise because I had to crank up sensitivity, again, because the scene conditions aren't great. But just imagine you would see this as a large oval because it's a spiral galaxy on edge. So face on, you get the nice spiral arms like a pinwheel. Edge on, you get just a fuzzy line with sometimes dust lanes going through it and stuff like that. And oblique angles like this are between face on and edge on. So you've seen, most likely you've seen pictures of this before. In fact, I'm using a really nice picture of this from somebody as my avatar for my channel. So if you look at my AstroAddict6313 channel icon, it's the Andromeda Galaxy, what you're looking at right now. Usually in a good picture and a good night, even with your eyes and a scope, you can see 3 galaxies in the field of view generally. You see the majority of them in Andromeda Galaxy called M31, named after a group of objects, a comet hunter called Charles Messier, cataloged so he wouldn't get confused all the time. Is that a comet? Oh, that's that damn galaxy I already found. Or a globular cluster or some other kind of fuzzy object. At the time, with his optics, things mostly seemed kind of fuzzy. So he made a catalog of all these objects. So they're star clusters, gas nebulae, galaxies, globular clusters, various other things like that. And they're bright enough and they're big enough for him to find regularly. He just put them in a catalog called the Messier catalog. Originally about, I think, 60 to 80 objects. I think closer to 90 objects when he stopped doing it or when he died. And then they became such famous, popular objects for amateurs to enjoy because they're bright enough to be seen easily with a modest telescope or binoculars or sometimes naked eye like this one. And so they continued to add to it. So it went from his original list to like the last official count, I don't know, 30 years ago, 40 years ago, or maybe more, was M110, which is the same as NGC205, one of the companions of the Andromeda Galaxy. There's another companion called M32. So this is M31 is Andromeda, M32 is the companion, and a little tiny companion off to the side, kind of perpendicular to the group, is NGC205 or M110. That was the last kind of official one added to the group, and then they said, okay, that's enough. We already kind of bastardized his list a bunch, but it's a great collection of objects for beginners and just fans of the stuff for public events and just, hey, I want to see this, want to see this. It's usually go-to things that people enjoy time and time again, no matter how many times you see them. Great for photography, great for challenging. How good are the conditions tonight? Well, let's see if I can see this object. Oh yeah, it's pretty good, so it must be a good night, that kind of stuff. And then this, one of the guys who published Astronomy magazine, I think his family name was Caldwell. He started coming up with this thing called the Caldwell objects, the Caldwell list. He took a lot of the Messier objects, the NGC objects, a few other objects, and called them Caldwell objects, C something or other. And but there's so many way before Messier. There's NGC, there's IC, there's all these other different catalogs out there for people studying. Ooh, is that a bat that you found there? Oh, that's some bats flying there. Interesting. Oh, it could be that owl. Actually, that's pretty big. That's probably the owl. Silent flyers, man. I didn't hear a thing. Just saw a shadow. So that's what, because the moon is out really bright, so I can see everything. That's why if the moon weren't out, it'd be easier to find the comet than I probably still could barely see it naked eye, but most likely not, because your eyes get more dark adapted and stuff. But it's just, if I took a time exposure right now, just a few seconds, you would swear it's daylight. It's so bright. Anyway, so that's Messier stuff. I'll get a little bit of drift here. Assuming that at the bottom center of the frame is the object, if I stop So I can't get it more focused than that just because it's not looking great right now. And I already know it's in focus because the moon was perfectly in focus. So I'm not going to worry about it. Just fix my exposure a little bit. But you get the idea. You can see a good portion of it. It's not the whole object. We're just seeing basically the nucleus of the galaxy. So it's kind of a soft oval, but in a nice view with your naked eye. With a telescope view or a picture, you can see this giant disk, which again is not edge on, it's not face on, it's oblique angle between edge and face on, so it's this kind of long extended oval. And it's huge. It's almost, I would say, if you're able to expose the entire thing and then move it next to the moon, it will probably be half the size of the full moon, fully exposed, I'm guessing. But that's how big it is. So the part you can see naked eye is, a good chunk of the moon. If you superimposed it, it would look bigger than one of those mare that's on the moon. Slightly bigger. So it's a good sized object in the sky. Now the moon, of course, is very close. It's 250,000 miles away to 300,000, somewhere in that range. Whereas the Andromeda Galaxy is 2.2 million light years away, which is, I don't remember the exact figure in miles, but pretty easy to look up. Just, again, astronomical sizes. It's 2.2 million light years. Our closest neighbor, star-wise, Proxima Centauri, part of the Alpha Centauri group, is just over 4 light years away. So 4 versus 2.2 million, it's quite a distance. But in big distances in our solar system measured in astronomical units, AU. So 1 AU is the mean distance from the Earth to the Sun, 93 million miles. Now, because we're on an ellipse, like all the other planets are, elliptical orbits, just like an ellipse in mathematics, an ellipse has 2 foci. It's not a circle, it's an ellipse. So the Sun is at one focus, and there's nothing at the other focus. So that's why when we go around the Sun, we have this variation in distance from the Sun to the different planets, because the Sun's at one focus, one of 2 foci, those elliptical orbits. And you guys are getting here now. It'll be quite neat to hear. So yes, scales are crazy. In fact, I highly recommend, I showed it on several of my live streams on the iPhone front. Get the app called, I think it's called Extrasolar, Exoplanet, I think it's called Exoplanet. It's extrasolar planets they found throughout the known universe. So they started doing these surveys a long time ago. I actually had a friend who worked at NASA, or NASA City, but also did some research for other branches. And I actually went up to Mount Hamilton once with him. One of the big telescopes with liquid nitrogen cooled cameras, snapping off CCD frames of some candidates he was studying for stellar wobbles. Before they had proper instrumentation and fancy computers and other kinds of cool tech they have now, they would just take photographic plates, either with film or in this later, like he was doing CCD images on a computer, and you just snap frames. And you pick an interval you snap it at, and exposure, and duration, all that kind of stuff, and you just snap, and you go back and analyze the frames later, and kind of like a blink comparator style, jumping between frames. Almost like old school animation, flipping through cells. And you watch for positional changes of the star in the background. Now, they're very, very small measurements, so you have to get really good images that you can blow up and study very closely the movements. And you see these little changes in the star in the background, or in its over a period of time. You see this wobble, and the wobble again is caused by stuff going around it, because it's also elliptical orbits, just like we have the moon's elliptical orbit around the sun, around Earth. Earth is elliptical orbit around the sun, etc., etc. And because of Newton's laws of motion, the Earth is causing us to move, but we're also causing the sun to move very, very slightly. There's a synergy there. And so we have, if you went to study our sun from a long distance, you would clearly see a stellar wobble because of all the planets going on. So many planets, these gas giants. So some of the smaller movements of a single planet or a small system of planets, you can stellar planets to study, especially with the old techniques. So this guy was snapping up all the photos. We're up to just chatting. We gave him a tour of the facility. We looked at some stuff with a telescope, and we did some actual research. Just being out and chatting while he was snapping off research frames. And then we had a long drive back to the valley. It's a crazy drive. And so decades and decades later, they have all this data with new systems and the old data and actual confirmed planets going around other stars, extrasolar planets. And this app now tracks thousands of them, just thousands and thousands of them. But the app is so cool, they scaled it up. So it doesn't just show you the planets go around the different stars, because those stars are in our solar, or in our galaxy, right? Well, you continue zooming out, and you can leave our galaxy and go out to look at other galaxies and their relationships to each other in 3D. So it's a really powerful app, and it goes all the way, you can zoom all the way back out to 200,000 megaparsecs. So you're going to AU, and you're going to parsecs, and you're going to kiloparsecs, megaparsecs, to the cosmic background radiation, the farthest they can measure right now with our known instrumentation. The cosmic background radiation. So Exoplanet is a great app. Get on your iPad, iPhone, whatever, and you can see these distances. And you can see the groups. So Andromeda Galaxy, the two of the galaxies next to it I mentioned, M33 and Triangulum, another we call the Pinwheel Galaxy. It's a face-on spiral. And the Magellanic Clouds you can see from Australia, Southern Hemisphere, and stuff like that. Those are all part of the local group of galaxies, our group of galaxies. So they're neighbors, but they're all so damn far away. It's crazy. Magellanic Clouds are much closer. They're I think like 20,000 light years away, something like that. They're much closer than millions of light years. But something in our local group, 2.2 million light years, is still considered part of a local group. That's how big everything is. And then you get into other stuff where you get galaxy formations and regions of known space which are voids, except for probably dark matter. But as far as like these weird kind of structures, superstructures of galaxies. There's one called the Sloan Wall. There's so many formations. In fact, I did a little extra research for fun during the hardware jam. We're supposed to talk about something about aliens, alien visitations, or I don't know, something about that. I did something about the Arecibo telescope, the radio telescope, and then I was doing something about the different galaxy distances and stuff. And so I actually did a bunch of just online research really quick, just to get the facts straight on the names, the distances, and the orders. And I went out to different distances of different galactic formations, all the way out to the largest known ones that have been studied. And it was just really fun to just for a fun little dopey music thing, to get into this stuff I never really read much about. It was a good excuse to read up on them. And just, it's amazing how much stuff they discovered, the structures of the universe, and how much still isn't known because of dark matter and other things we just can't measure from here very well. But the stuff they have measured and calculated and figured out with supercomputers and a lot of diligent people doing even long-form math to get this all figured out, to the point where you have this app you can just carry around in your pocket and be spoiled with all this cool information. I think I just got some drift here. So. There it is. I was chatting so much I'm on the screen. I'm way off kilter now. This thing's, the polar alignment's terrible right now. But that's Andromeda Galaxy. Again, not much to write home about. It's a big fuzzball. And because of the dancing of the atmosphere and the noisy, amplified image here I have, it's definitely not ideal. It looks like it's underwater. I can't get any actual nice detail out of it. But with my DSLR camera set up with the higher ISO capability and much sharper image, much higher density of pixels. I've shown it before, but I'll show it again on the stream. So, again, this is just screwing around after the comet. And so I'm gonna, like I said, I'm gonna edit all this together, put it in a single video with some music from Henrik, and do a YouTube premiere, and we can have a chat while it's playing. I'll cut some of this down because I yak too much, but some of the information is probably interesting to some of you while I'm showing the images. So I'm not going to cut all of it out, but people have tolerance for so much, so I don't want to be too boring. But with that in mind, I'm probably getting low on battery here, both from my clock drive, because it's cold out here, and also my iPhone might start to get kind of low. So I'm going to call it there. So thanks to everybody who watches this later on the premiere. Hope it turned out as well as maybe expected. Like I said, everything was wrong tonight. Not enough signal for streaming live in this specific location. Further up the road it was good, but this is a better night tonight. And nobody was here for the most part, so it was for that. Also had pretty decent view of the comet, even though it was getting low and a little bit hazy. So that was fun. And I had, just again, it's a bolted iPhone onto the eyepiece telescope. So I didn't get to use my nice mirrorless camera, and I get to stream it live and do all that stuff. So consider all that, I still had a good time. And I hope you enjoyed this. And one more time, I'm going to shoot. What is it? nice laser, right? It's much more impressive. Let's do the same thing. So that last laser is a low battery, so it's not full power. But when it's full power, it's about 15 to 16 milliwatts, something like that. This one is supposed to be full power, 75 milliwatts. Very dangerous to point at anybody or anything. But should be very impressive here. Even though the battery is also kind of low here, it's not full power. Check this out. Because it diverges so much, it looks huge. So yeah, there's a little ET up there, hovering in between me and the galaxy. Yeah, definitely don't point this at pilots. If a plane was going overhead right now, I would not do it because it would hit the plane. It might be very diffuse by the time it hits them, but they would see it from the ground, they might be distracted. It wouldn't hurt them at this distance, but they would certainly call it in and they would get busted. Because pretty easy on a dark hill, a beam coming out of nowhere, especially when it's a known road. Cops come right here and kick my ass. So you don't want to be irresponsible with this. You don't aim it at people, don't aim it at cars, don't aim it at airplanes, wild animals, anything. Don't let kids get a hold of it. It's very dangerous, but it is fun, as you can see. It makes a nice little demo on the video. But yeah, you gotta be careful with this stuff. It's the great power comes great responsibility. Full screen. Let's go off screen. Now bring it back for a little second here, just so you can finish on a fuzzy galaxy image. There we go. It's on the bottom of the frame there. Well, I found one more thing before I'm packing it in. Yes, you may have guessed it. It's not perfectly set up yet. It's just overexposed and stuff because of this dumb app. But look at that shape. Got a big ball and several little balls. What do you guys think that is? You haven't guessed it yet? Here we go. Let's go. Jupiter. Look at that. 3 of the 4 Galilean moons all set up for you. I don't have the moon app ready, so I don't know which is which right now. But one cool thing is I get regular updates from my One Astronomy app, and it tells me when shadow transits are happening. So when one of these guys goes in front of the planet from our point of view, and it's just the right angle, you'll actually see it cast a shadow right in the disk of Jupiter. I actually had a really nice view. Was it last summer? Last spring or last summer? Yeah, it was summer, after NAM. I had my telescope with me coming back after NAM and stopped in Yosemite for a night. Just got lucky. It's like, look at some stuff. Maybe take some pictures. I wasn't able to, wasn't it summer before? Actually, summer before. A different day. And because last summer I did a live stream. I think. Did I Astro live stream? It's all a blur right now, I can't remember. In any case, I had just my scope that was the night. Yeah, that was the night I couldn't make it to Glacier Point because the road was closed for work or some fire stuff or whatever. So I had to go to this crazy place called Olmsted Point, which gives a similar view facing the opposite way of Glacier Point. So you see Half Dome as well, but you see it from a different angle. And instead of facing out toward Half Dome, facing back toward Glacier Point and Half Dome. So see more stuff that's behind the trees at Glacier Point. It's sometimes hidden because it has a kind of a high horizon with the way the amphitheater is set up there. So the view is pretty good, but it's a much more exposed area, much more windy, and so it's a lot colder because of that. And just not quite the same altitude and stuff, so it's just not as stable, not the best, not as good a view as Glacier Point is. Glacier Point's like perfect, but anywhere in Yosemite, as long as the weather's decent, is nice. So I was happy being up there. Set up my scope, looked at a few things, said, oh, Jupiter's up, let's go check out Jupiter. And right when I got it into focus, I'm like, whoa, this isn't normal. There's a shadow transit going on. It's so obvious I could see it immediately. Nice little dark circle on the disk going across. And then I had to look it up. Which shadow is it? I don't know. I wasn't watching. I wasn't paying attention. So then after I installed these apps, I turned on the notifications. And now it tells me all the time, Io is now transiting. Ganymede is now transiting. It'll tell me. So if I'm ready and I feel like it, I can go check it out. But you know, this is a narrow window. You only have so much time to see these transits. So you can plan ahead, of course, but it's kind of nice to have the reminders when it's happening. To me, it's more exciting than a dentist reminder. So, so anyway, that's Jupiter with 3 of the moons. Fix the exposure here. One thing I have some control over. Again, the YouTube app doesn't have this. Let me zoom in a bit and let me fix the location here. Okay. Now the only trick is in my exposure and my focus. I think the focus is probably pretty good. No, it's still a little fuzzy, I think. Let me try to adjust this. There we go. Again, the scene is not great, so that's also making it a little bit fuzzy. It's unfortunate about as good as I'm going to get it with these conditions. But if you look carefully, you can see equatorial belts there. So I had to expose for the disk, which made the moons drop out. Notice the moons aren't visible now. Because in order to expose for those little moons, although they're pretty big, they're little compared to the disk and the brightness there. It's a tight dance to get. You see one or the other pretty much. So I wanted to show the disk, and you can see some features there a little bit. I'm gonna have to maybe enhance this a little bit after I pull the video down. Maybe put a few images in a stacker and get a better single frame out of it. But you can see some structure there. You can see some equatorial belts at least. The edge is a little fuzzy, but again, it's not prime conditions, and being bolted on a eyepiece isn't always the best view. But yeah, it's definitely Jupiter. Large, got the markings on it. You won't be able to see the red spot at this point if it is indeed visible. You know, in recent years it's been more of a pink spot, a washed out spot, and then back to red again. So I'm not sure if it's always a little bit of a pinkish color, but it's got pale before. I haven't kept up with it, so this gives you a basic idea of the disc though, and this is again not high power. Again, I'm not using an eyepiece since the phone is the eyepiece right now. Well, actually, I am using an eyepiece, but it's also being modified a little bit beyond the eyepiece with my zoom. So it's a 22mm eyepiece. So I would guess, plus the digital zoom a little bit. This is maybe 100 power, something like that. 120 power, maybe more, something like that. That's actual math. So that's what Jupiter looks like. So when you see these glorious blown up pictures of Jupiter, people are taking a very high res image, the best they can, they've blown it up. To get much better images, you have to basically blow it up. And I have a zoom eyepiece, so with my eyes I can actually see a bigger image in the scope, but it won't translate well to this kind of setup. It'll just be, especially again when these conditions are kind of cropped tonight. So that is that. I'm going to go back to this again. Now I can see the moons. I'm going to drop the exposure down a little bit so the disk looks a little bit better, but you can still barely make out the moons. Let's see, if I go too far down, the moons will drop out. They're just too faint compared to the bright disk. If you heard my chat the other day about magnitudes, visual magnitudes of the stars and planets and stuff. The sun is like -23 or -26, something like that. Jupiter is like -2 on a good night when it's really close and really bright. And then the farthest away the brightness can get for your eyes to perceive something naked eye in a good condition is usually about 7th magnitude. So the higher the number, less negative the number, the dimmer it is. So Pluto can be like 12, sometimes 10, between 10, 11, 12, something like that, maybe higher, based on its orbit and some other conditions. And so that's faint. It's a logarithmic scale, so it's a huge jump going from one whole number to the next. Going all the way from -20 something to 7 obviously is huge. You stare at the sun, you go blind to something you can barely perceive at night at 7. So yeah, a little bonus there. I was about ready to end because I wanted to go back and get Maker Fair tomorrow, so I want to have fun. I spend the entire day there instead of the drive, so I don't want to stay up till tomorrow and rest. I'm still a bit wiped out for Ramsey. I had a nice nap and it wasn't as long as I wanted to. But Ramsey show's a lot of fun, but it's tough sometimes in the morning. So that is another sample of crap tonight. Let's go back and look at that. I'm just going to try to get dimmer so you can see the disc again. Kind of see it, but it's still not great. Let's see, I've already wiped out the moons. I brought it down so much, the moons disappeared. Anyway, that was my last little bonus thing. I just said, I wasn't looking closely at that. That's a bright object. And it's not moving. Oh, damn, Jupiter's already up. I wasn't counting on Jupiter being up. I haven't watched it for a while. So yeah, good stuff. If you're looking for Jupiter, now that I've found it, because I forgot it was up tonight, if you're looking for Jupiter and you go outside, right now it's, well, the moon basically, moon's in the same place in the sky 50 minutes later every night. So right now, the moon is about 2/5 away from Jupiter at arm's length. So that's, this is about 20 degrees, I think. If I remember correctly, I read about this years ago and it was a cool trick, but I forgot the exact number. 2/5 right now. Tomorrow, it'll be much closer by the time the moon comes up again. And the moon will also be more faint because it's a waning gibbous moon. So if you're looking for Jupiter and you have a clear enough sky, look for the moon tomorrow night if you're up this late. I don't know what time it is right now because my app won't show me. And then it'll be much closer to Jupiter tomorrow night than it is right now. So that should help you find a very bright star in the sky. It doesn't twinkle much because it's so big. Even when the sky's not so great, it's less twinkly. That's another indication of a planet usually, but not always. And you know where the moon is once you've seen it come up. So just look for a bright guy below the moon by tomorrow night or subsequent night. So there'll be a conjunction coming up. I got to figure it out and try to get some pictures of that. Anytime two objects or more come together, loose grouping, or right next to each other, or even touching each other, I call it a conjunction. If it's real close at an angle and it just grazes by, they call it grazing. That's a really cool event. If it goes in front of an object, it's called an occultation. So the moon at some point looks like it's on trajectory to do an occultation with Jupiter in the next few days. Will it happen during the daylight hours or the night? I don't know. I have to look up ahead of time in some web article or in one of my software programs. But that's another cool event because you can actually, the moon moves fast enough in an evening where it can actually cover up a star, reveal a star or a planet, and so you get this occultation that changes in the same span of a couple hours, and that's pretty fun actually. So that's something you can see without equipment. You can just watch it, two bright objects interacting, get binoculars maybe if you want, and watch it. Or get your camera with a big lens, take a bunch of exposures, and you can make a lot of animation. So, good fun. Alrighty. Things are holding up actually. Could hang out here and look at some stuff, but without the right camera set up and the live stream, it's just not as fun. This live stream from the phone is okay, but it was a half-assed attempt, and it worked out okay, but it could be so much better if I actually had the proper camera hooked up and the stream going. So thanks everybody. So this, like I said, this will be premiere streamed later on. Catch you later.